David Can here with another question from the question bank in the style of what you find in your Hayes and Harris Math SL textbook in Chapter 10K. In this question, we're given a monstrous equation, and we're told to solve it on this domain, one full rotation for x. That means we're going to have to do a lot of cancellation here, so we're going to want to look for some things we could take advantage of. The very first thing I notice is I have cosine of 2x. But as we know, there are three different equations we can use to replace cosine of 2x with, and it's not immediately clear to me which one of the three I would want to use. I do notice that we also have cosine squared and sine of squared, which could be a double angle, or it could be Pythagorean theorem. It could work out to 1. So the very first thing I'm going to try is I'm going to try and combine these two and see what they become. So I'm going to move the cosine over to the other side, try and combine it with sine. That'll give me cosine of 2x, take 3, cosine of x, so I haven't manipulated anything, take 3, haven't manipulated anything, but now I'm going to add cosine squared of x to the other side and get sine squared of x plus cosine squared of x, which is Pythagorean theorem on the unit circle. That all cancels to 1. So on this side we have 1. All of that is gone, which starts to give me clues about what I want to do with this double angle. I have a cosine, no sines, so I think what I'm going to want to do is replace cosine of 2x with the only equation that has cosine only. So cosine of 2x can be many things. It can be cosine squared of x, take sine squared of x. It can also be 1 take 2 sine squared of x, and it can also be 2 cosine squared of x take 1. But I think that I'm going to want to use this one because it only has cosine, and that's all that remains in my equation. I've gotten rid of all the sines. I think that'll work out the best. So I'll replace it with 2 cosine squared of x take 1, and I have remaining 3 cosine of x and take 3. And when I make that substitution, what I see now is that I have another quadratic. I have a squared term, a term to the first power, and a few constant terms which I'll want to combine together. So let's rearrange this and put it in a familiar form for a quadratic. I'll get my squared term out front, followed by my term to the first power, and then my constants. So 3, negative 3, take 1 is negative 4. Take 1 is negative 5. Now that I have everything equal to 0, I'm going to try to factorize. See if it works out cleanly. 2, not many choices. It's just 2 and 1. 5, also not many choices. It's negative 5 though, so it's either negative 5 times positive 1 or positive 5 times negative 1. I want more negative numbers than positive numbers, so I'm going to bet it's negative 5. Negative 5 times 2, though, is too much. That gives me negative 10. That's way off from 3. So I think probably I want to multiply my negative 5 by 1 and leave positive 1 to be multiplied by 2. So let's double check. Let's see what we got. 2 times 2 is 2. Negative 5 times 1 is negative 5. 1 times 2 is 2. Negative 5 times 1 is negative 5. Negative 5 plus 2 is negative 3. I think this factorizes correctly. Now that I have it factorized, what I have are two expressions which are multiplied together, and they both give me 0. Or sorry, and the result gives me 0. This is the null factor law. What that means is that either or both of the expressions must be 0. 2 cosine of x take 5 has to equal 0, and or cosine of x plus 1 has to equal 0. Let's try and solve each of these for x. Cosine of x is equal to negative 1. Add the 5 to the other side and divide by 2, and we get cosine of x is equal to 5 halves, which is a problem. 5 halves is 2.5, and as we know, cosine and sine are always between negative 1 and 1. never outside that range, never greater than 1. So there are no solutions to this half of the equation. This cannot equal 0. And so the only solutions are over here. What are those solutions? Well, let's draw in a unit circle. What we're asking ourselves here is, what value of x has a horizontal component of -1? -1 is all the way out here, and so that would be half a rotation, pi. We have to keep in mind our domain. 0 has to be less than or equal to x, which has to be less than or equal to 2 pi. So we're restricted to one positive rotation. So within that one positive rotation, the only time we have this angular displacement is at pi, which means that x is equal to pi and pi only.